Hello everyone, welcome back to OneTouchBI. My name is Saravanan Vajravel and today we are going to learn TensorFlow Deep Learning. With the help of deep learning, we are going to create a custom trained data model using the Keras package. First and foremost, why do we need custom trained data model? Why don't we leverage on the existing pre-trained data model on the Keras package itself? That's a valid question, but in reality, you can't depend on the pre-trained data model from the Keras module always. There are certain scenarios will arise where you need to be dependent on your own custom trained data model. And that's exactly we are going to address in our today's tutorial. As you see in the diagram below, that is the high level understanding that how we are going to use deep learning, the Keras package inside the TensorFlow on reading any of the images. Any images you're going to read, that will be always resized to the dimension width by height, that is 224 by 224. That is how the deep learning Keras package is being designed. If it is a colored image, you will have three different layers. If it is a non-color image, it's a one-dimensional array. So it's clear on the first part. And in the second part, hope you have seen in the previous tutorial, Mr. Kalyan has explained how to extract the selective image. In that, he has given a brief introduction about how the images are read in the computer vision. All the images will be read either in black or white, and always that black and white will have certain numbers associated to each of the pixel. And that's the reason you see in the second layer from the first layer of the image, which is in the colored BGR format, which is converted to the grayscale with no colors in the layers. So that's the second exercise we need to do. As you see in the legends are showing the block box. First one, convolutional ReLU, and the second red one is max polling, and the third is the ReLU fully connected, and the fourth one is softmax. In our today's exercise, we are going to use softmax and the ReLU. The softmax is nothing but how many different types of images you have. That's why you see in the very beginning of the entire image extraction diagram, you see the very first box. As you see my mouse cursor, that is what the softmax. This is going to apply the normalization, but here you're going to define the number, how many different types of objects you have. Accordingly, you will apply the softmax algorithm. And the ReLU is nothing but rectified linear unit. That's another form of linear regression we apply for training our data set. In our today's tutorial, we are going to use softmax and ReLU. Softmax defines how many different types of data set you have. For example, orange and apple. In that case, you are going to provide the softmax the first parameter 2 and then apply the softmax algorithm to get the normalized result set. And the ReLU activation we need to do before we perform the softmax. As you see in the sequence, ReLU comes first and softmax comes in the last. ReLU is nothing but a rectified linear unit. It's another linear regression algorithm which we need to apply to get the linear regression curve. And top of that, we'll be applying the softmax normalization. Let's not take too much into our brain. Let's move on to the next slide. This is the data set I'm going to use for our today's training. I have one data set, training, and the other one is test. In the training data set, I have apple is one data set and orange is another data set. As you see under apple, I have 17 different images, and in the orange I have 7 different images. 17 plus 7, it is 24 images. I'm going to train it using the TensorFlow Keras package. After I train the model, I'm going to save the model in my local system, and later I'm going to pick up this testing data set. In the testing data set, again I have under Apple 6 and Orange 3. These 9 images I'm going to pass it on the trained data model which I already saved with 24 images. Now these 9 images will be sampled and analyzed against the pre-trained custom model what we have with 24 images, and any close sampling is found that will be mapped back and returned to the end user mentioning that it's apple or orange. Let's see how much accuracy it's going to bring up. As said in the beginning, any machine learning is not going to be 100% accurate. We can make it to the max of 99.9% accurate, or I would say 90% accurate. The 10% always we should give a room for improvisation. It will be keep on improvising. There is no end for the improvisation in the machine learning world. With that assurance, let's quickly head over to my Jupyter notebook and start writing the code from scratch. Are we ready? Create a new Jupyter notebook by clicking on File, New Notebook and choose Python 3. Before we make a program, I want to make sure that you have the prerequisite. If you're working on the Windows operating system, make sure you have Windows 10 or Windows 7 Plus installed. Second, you need to make sure you have installed Python 3.5 plus, and it should be less than or equal to 3.79. I will give you the reason why you need to be under the 3.79 version, because the version anything goes beyond 3.79, your Keras and TensorFlow package is not going to be installed in the Windows, and with that restriction we have to make sure that your Python version is 3.79 the maximum. We have in market 3.90 also the latest Python, but in order to work with TensorFlow and Keras, you downgrade the version to 3.79. Okay. So once you met this prerequisite and you install the TensorFlow successfully, there you go. From there you can follow my tutorial and start coding it from scratch, and you get the answer what you see in the screen. Without much delay, let's start programming it. Let's comment the line to say what is that we are going to do in today's exercise. So comment the line with hash, create a custom trained data model using TensorFlow.Keras package. Of course, we know what are the packages we need to import. Import TensorFlow. I will be aliasing this as TF. Import CV2. That's a computer vision package, OpenCV computer vision. And third, I need matplot lib.pyplot as PLT. This is the one I'm going to use for showing the image in the plot. And then I need numpy, because we are going to store in the form of array, numpy as np, and then we need the import OS package. That's the one we are going to use for defining the folder path, directory, all that. Okay, we are good. Just run the code by holding shift and enter. If you're not encountered any error, we are good. And next, we need to read the train data set with the supervised learning. So I'm going to name it as read the train data set with the supervisor labeling. Now let's assign to the variable train equal to the path where your image is stored. In my case, the image is stored under images/train. As our comment clearly says, we need to apply the supervisor labeling after we read all the 24 images, that is 17 images from the apple and 7 images from the orange. So we need to call a function to perform that action. So let's define the function name. It's called label supervisor. Okay, once you create the label supervisor, it will look for that function to be defined before you call this supervisor function. So let's define the function to apply labels. Okay, to define the function, you need to use the keyword def function name. What is the function name? We have used label underscore supervisor, copy paste it, and we have passed the image directory. Let's call this variable as image dir. To continue coding inside the function, we need to go with colon. Under the train folder, I have two sets of images. One is orange and the other one is apple. Let's provide them. Apple, comma, orange. Okay. Now we need to go on reading the image in the loop. So what I'm going to do, in the for loop, I'm going to read the images inside the train folder, apple followed by orange. So label in labels. The labels is going to have apple and orange, two values. I'm going to interpret twice. Now I'm going to assign to the variable path. Using the OS package, I'm going to stitch the directory. The directory what has been passed, image dir, appending with apple. How do I do that? There is a function called os.path.join. As you see, it is going to take the input path. What is the path we have? img dir, followed by what is that second one we need to stitch? The apple. So let's pass the actual directory where your image is stored. That variable is called img underscore dir. What is that you want to join? Inside the train, I want to read images from apple and orange. Apple is got assigned to the label. So let's pass the value label. Okay, now the directory path has been framed. Now what we need to do, we need to get inside the folder, that is images/train/apple, and read all the 17 images. That means it's going to return more than one images. We're not sure how many images it has. So for that, we need to go on using another for loop to iterate all the images. For I'm going to call file. In there is a function from OS package, os.listdir of the path, the one which we have assigned temporarily. Now this is going to list all the files inside images/train/apple. Okay. Now we have the file complete path. All we need to do is we have to read the image. I'm going to read the image and assign it to the image variable. Image equal to cv2 dot imread of the file, the one where the image is getting stored, and this image will be read in the form of BGR format. We need to convert to the RGB for displaying using the matplotlib library. I have shown in my previous tutorial how to convert a BGR to RGB. You can use that mechanism, or otherwise here is the new command where we can convert within the imread function in line itself that I'm going to show you. You need to open the square bracket with triple dot separated by comma, colon, colon, followed by -1. That's it. This will convert into RGB. Now you read the image. What is that next we need to do? We need to resize the image. Assign it back to the same image. cv2 dot resize. If you're not sure, the resize is going to take the source image, that is img, and the second one, the size of the image. The size of the image, I said the deep learning is going to use the 224 by 224 size. Provide that within the parenthesis 224 by 224. That's it. After that, we need to assign it back to the array. Inside the apples folder, whatever images I have, all that image I'm going to store inside a single array. I have many images inside the folder apple. I'm going to read all the images and assign it back to the array. So in order to assign it back to the array, make sure the array has been created. We're going to provide the array name as img array equal to empty. Now what we need to do, img array dot append. You're going to append the image. I said any image using the computer vision library or any other package, it will be always read in the form of numbers. So this array result, we are going to append it to the empty image array what we created, so that all the images will be appended into a single variable. Let's do that. Pass the image variable, and the second column I'm going to define the supervisor label. What is the label of this image which I'm reading? It's apple. When I'm reading the orange, it should be orange. So apple and orange is distinguished with a variable called labels. Let's take the index of the labels. How do you take the index of the labels? We have already taken apple and orange from the labels. I'm going to pass that. Are we good until here? Now we need to return the result. That is return of img array. That's it. Now the value is assigned back to the train variable. We did one mistake over here. In the array, I'm going to keep two-dimensional information, img, and the second one is labels. When I'm going to keep two-dimensional array, I have to define within the square bracket. That is the one we missed. Let's add the square bracket and then we are good. We've done it. Let's check that this function is valid or not. Yes, I'm not getting any error. We are good. Are you getting the problem in my function? I took the directory and then appended the path apple, and that path is passed here. After that, I'm using a os.list directory to list all the files, and that file names are getting printed in the file variable. And that file is not going to have the full qualified path of the image name. So we need to again make os.path.join of the path followed by the file name. Now you see it will go fine. Now it looks fine. So what is that next we need to perform? As we all aware, the train is going to hold two-dimensional information, image array and the label. Let's extract them separately using the xtrain and the ytrain, because our TensorFlow Keras needs information in the form of xtrain and ytrain. Xtrain is the array, image array, and the ytrain is the supervisor label. Let's split it using the explicit variable. I'm going to call it as xtrain and ytrain with the empty dimensional array. Now in the for loop, I'm going to iterate the train and assign it back to the xtrain and ytrain. For x, y in train, I'm going to make xtrain dot append of x, and similarly ytrain dot append of y. We have split it, and xtrain is getting extracted and ytrain is getting extracted separately. We are good. Let's label this code extract xtrain, ytrain. Now what is next? We need to apply the normalization. To apply the normalization, we have in the TensorFlow and the utils package, there is a function called normalize. Let's do that. Apply the normalization on xtrain. Xtrain equal to ef dot keras dot utils dot normalize, and pass the xtrain array. Xtrain, and I'm going to take only the axis 1. Give a quick introduction on axis 1. Axis 1 is nothing but you have an array 1, 2, 3, 4, 5, 6, 7, 8, 9. If you see 1, 2, 3 is represented as axis 1, and 4, 5, 6 and 7, 8, 9. When you say axis 1, it will be read in horizontal. Okay. When you say axis equal to 0, it will be read this way. The same output I'm going to make. This is with respect to axis equal to 1. With axis equal to 0, this will be read in this way. 1, 4, 7. And similarly, it will be read in the loop iteration 2, 5, 8, and goes on. So now you understood how axis 1 is interpreting and axis 0 is interpreting. So we are going to interpret in the horizontal line by line. That's why we defined the axis 1. I will remove these lines. We have applied the normalization. Once you convert into normalized format, what happens? It gets stored in the list object format. We need to convert it back to the NumPy array. That's our next activity. So let's convert it back to the NumPy array. xtrain equal to np dot array of xtrain. Good. Now let's create a TensorFlow custom model using Keras. For that we need to create a variable called model equal to tf dot Keras dot model dot sequential. Sequential is the most standard and familiar model used for any custom model creation. I'm going to use sequential model. The syntax for creating a sequential model using the Keras is models dot sequential. Now what we need to do, we need to flatten the 224 by 224 colored image into a flattened structure. Let's do that. Model dot add tf dot Keras dot layers dot flatten the BGR into gray. The gray images are always in a flattened scale. Okay. Now what we need to do, after you flatten it, you have to dense it. Model dot add, copy this so that we don't need to type every time. Dense. There is a function. In the dense, you need to pass units and then the activation method. The units you are going to provide how many neurons you want to keep it for interpreting the image. I'm going to keep the units. It's 256, the maximum, followed by what is the second parameter? It's activation. I'm going to use the activation method called ReLU. I said ReLU is nothing but rectified linear unit. Very good. I ran it and saw that there is no syntax error. Go back to the code. After we dense it, we need to create a softmax normalization using the dense method. So under the dense, we need to first activate the ReLU activation, and second we need to apply the softmax. How many different types of objects I have? I have two different types of object, apple and orange. The softmax is going to be applied with 2 units. Let's do that. Model dot add tf dot Keras dot layers dot dense. Here I'm going to define 2, and the activation I'm going to apply softmax. We are good. Now we need to compile the model. Make a label. Here is the syntax. We created the model, and the model variable is model dot compile. And here are the parameters we need to pass. We are going to take, it has lots of parameters. I'm not going to use all of them. I'm going to use only the first 3. The first one is optimizer. I'm going to use the standard optimizer, that's called Adam. And the second parameter what we need to pass is loss. Again the standard loss predefined method, sparse, dot categorical dot cross entropy. And what is the third parameter? Matrix. Matrix will be written in array format. So I'm going to define with the square bracket and I'm going to read the matrix accuracy. Define it. Accuracy. Sorry, we missed the syntax. We need to separate by comma. I missed it. Now it should be fine. So we are done. We corrected the compilation code. Now the model is created named MODEL and we have compiled the model with the standard optimizer technique Adam, and the loss we are going to read with cross entropy, and the metrics we are going to take accuracy. Now we need to train the model. Train the model with train data set. Good. How we are going to train? Using the function, the variable what we have for the model is model, model.fit. Fit is the function. Here you need to pass xtrain and the ytrain in the NumPy array format. We have already converted xtrain, which was earlier in the list object during the normalization method. We converted later into the NumPy array format. We are good. And the ytrain is already in the array format. So ytrain we don't need to reconvert. We will leverage that. So let's pass xtrain, ytrain, and here we are going to define the epochs. Epochs is nothing but how many full pass you want to pass through your data set to train the model to the accuracy. I'm going to go with initially 3 epochs, and later I will show you why I'm going to increase my epochs for the more accuracy result. Okay. This error is occurred because it is expecting a class int, whereas it got passed with class list. So when you create a variable xtrain with empty array and ytrain with empty array, it is all getting stored in the form of list object. So I said it is not required to convert, but we need to convert into the array format explicitly. Let's do that. Over here, I will introduce a variable ytrain equal to np.array of ytrain. We are good. Run this code, run it. Now this should go fine without any error. There you go. Now you got to understand why we have made epochs 3. It is going to train the image. The image what we have 24 images, apple and orange together. With the 3 full pass, it is going to train the result. You may not get the accuracy because of 3 full pass, because you are looping the image 3 times to read and make the accuracy numbers. In general, to have a higher accuracy, that is 99% accuracy, you need to have lots of images to train. As we have gone with a limited image, what we can do, we can increase the epochs to 10 times. So I already have 24 images. 10 times of 24 image, if you read it, it's like 240 image. So you're going with the 240 samples to train the data. That's the meaning. Now you see that your accuracy is getting increased 0.7, 0.8. In some cases, there is very little rejection is happening. The accuracy is always read 0 to 1. So when you see anything closer to the 1, it's having a high accuracy, and over here you see that the loss is very high. So let's increase the number 10 to 50 and watch it. You can see now the accuracy is increased marginally very high. The loss is very minimal. So this way you can make sure that how you can increase the accuracy by increasing the number of epochs to train the model. So now we train the model with 50 epochs. Now let's save the model, and this model will be saving to our local drive. How do you save the model? It's simple. Model.save and provide the model name. The model name, what I'm going to keep it as OneTouchBI, that is OTBI underscore custom underscore trained underscore sample dot model. The model got saved. You can ignore the warning. Now what we need to do, we need to take the test images and pass it to the saved model and see what is the outcome. For that, what we need to do, let me label this saved model. Read the test image from the test directory and assign it to xtest. Okay, let's do that. Test equal to, already we have a function called label supervisor. Let's use the same one so that all images from the test folder, under test we have again apple and orange, all images will be loaded and return the variable. So let's use the same. So for that I need to use the same function, but in place of train I have to define test. Okay, now we read all the images from the test folder and assigned to the test variable, and this is going to return in two-dimensional array, that is image followed by the supervisor labeling. Here we are not going to use the supervisor labeling on the test. We are going to read the prediction of the images what we have in the test based on the trained data set. So in this case we are going to ignore the second dimensional column that is called y test. So let's explicitly remove the y labeling from the test result set. How do we do that? Using the for loop. Before that, extract xtest and omit y test, that is nothing but label. Okay, for x comma y in test, I'm going to extract only the x test. Before that, what we need to do, we need to create a empty array variable. I created the empty array variable x test. I'm not going to be interested on the y test, so I'm not defining that. Now what we need to do, x test dot append of x you have to pass. X is going to hold the image array, y is going to hold the label. We don't need the label, so don't assign it. Pass it to x test. We are done this. Now you come out of the loop. Now we need to calculate the x test normalization like how we did for the train. Just scroll up, copy this line, apply the normalization on x test and name the label it's test. Using the tf.keras utils normalize, we are going to apply the normalization for the axis 1 and convert this into the array format. We are good. change the label from xtrain to xtest, we converted, we are good. After we convert this, what we need to do is we need to predict the outcome. Let's check until here any issues on the code syntax. No issues, we are good. Let's predict the outcome. Before we predict the outcome, we need to open the saved model. So load the saved model. How do you load the saved model? Assign the saved model to the variable called OTBI underscore model equal to tf dot keras dot. The way you have saved the model, the same way you're going to load the model. Okay. tf dot keras dot models dot load underscore model, and within the parenthesis you provide the model which you saved. That is, copy this and paste it here. Now you loaded the model and you assign back to the OTBI underscore model. This is returning the error. The model named OTBI is not defined. You need to enclose this model name in a single quotes. Now you run this, it is fine. So now we loaded the model. What we need to do, using the loaded model OTBI underscore model, you have to predict the X test. Okay, let's do that. Predict the test data set against the trained model. What is a trained model in our case? OTBI underscore custom underscore trained underscore sample. That's the model. So let's pass our XTest image arrays to the trained model and see that it is predicting right or wrong. Here is the syntax. OTBI underscore model dot predict classes. The predict classes is going to extract only the supervisor label, which is closely matching the accuracy of the XTest dataset against the trained dataset. So the parameter what we need to pass here is, the first one is the dataset. What is the dataset we are going to pass? XTest, comma. The second and third parameter, by default, it is going to apply the batch 32 and verbose 0. So since we are going with the default substitution, don't pass it. This is enough. Now you print. And this is going to return the result. Let's assign the variable predict underscore class. Now in the predict underscore class, how many values is getting written? Let's print and see. How many images I have in the test data set? I have 9 images. I should literally get 9 results. Can you see? 3, 6 and 9. So it has brought all the 9 results set. I know that the first 6 are apple, 0 indicates apple. As you see, the label what we made, 0 is apple, 1 is orange. But it is not accurate. This should be orange, whereas it is showing as apple. That's what I'm saying. It is not that accurate it is going to make, but we can further fine tune this using the transfer learning that we will see in the next class. With this class, I'm going to make 90% accurate, and this 90% accurate, how we have achieved by increasing the epochs, the sampling rate. If you make, instead of 50, let's say 5000, you may get all 9 images predicted accurately if you are increasing the epochs to 5000. But I'm not doing that. This is just to make you understand how the customer train model is going to be created with a limited data set with a simple modeling technique using deep learning solution. Okay, with the 50 epochs I did it and it has predicted almost good. Now let's print the images with the predict class what you have taken. So display the test image with the predicted outcome and label it. Okay. Use the for loop to iterate all the 9 predicted outputs using for loop for I in predict underscore class. Display the images using the PLT, that is matplot library, plt.imshow of image x test of I. What is that x test is holding? X test is holding all the images. Can you see above? We have read the image using the label supervisor and extracted only the image values to the X test. After that, we have taken the axis equal to 1 and apply the normalization. This will correct the image because it will have only the normalized result set. We need to have the original source image. In that case, what I'm going to do, the normalized result, I'm going to assign it to the variable called xtestn, so that the original xtest variable will have the actual image values. It won't have the normalized value. You got it? And here you need to pass xtest normalized value. Now we are good. Let's print this. You will come to know how it is printing. You look at all images are getting printed in the loop, but we are not able to see all the image. We need to make a subplot for placing all the images. How many images I have in the test? Total 9 images. What I'm going to do, I will make a subplot by 3 by 3. If I make 3 by 3, each row I will have 3 images. So total 3 rows, 9 images will come. Let's make that plt.subplot of 3 by 3 and starting to print from all the way 1 to 9 images. So I'm going to substitute the variable I, len of predict classes. When you make a len of a predict class, this should be a number. So you need to make a range of len of predict classes. Now you see all 9 images got printed, but the labels are not displayed right above the image. Let's do that. So before you show the image, make sure plt.title and of text you have to provide. And the label is going to be dynamic. So how do you print the label in a dynamic way? This should be replaced with labels. We need to take that index I0 and pass it to the predict class outcome, and what is the value it is going to return. Predict within the square bracket, you pass the I value. Now what happens when it comes the first time, it's going to take the value 0, predict of 0, it is going to return 0. When it comes 1, predict of 1, it's going to return 0, and similarly 2 will be returning 0, and 5 will return 0, 6 will return 1, 7 return 1, and 9 will return 1. You got it? So when you're passing that appropriate value, so the label of predict of 6, what will return? The 6 will return 1, and label of 1 is going to return orange. The labels what we have, apple and orange. 0th index is apple, 1st index is orange. So we are good. Let's print the label now. Sorry, the label what I made is wrong. It's predict underscore class Here again we made a syntax problem. The labels is again an array value. The array you can call it using the open square bracket and the close square bracket. So remove the parenthesis and replace it with square bracket. Now we are good. Now you can see that the labels are getting printed dynamically. But it's not readable. What should we do? We should remove the x-axis and y-axis text, then it should be fine. How do we do that? There is a command called plt.showAxis. You need to print this value inside the for loop. Now it is fine. You got it? We removed the x-axis and y-axis while displaying the image, and finally we are showing the image. A quick recap before I wrap up the video. We imported all the required TensorFlow libraries and computer vision libraries. Then we have labeled all the images with the supervisor labeling. Then we have applied the normalization for the trained image. Then we created the custom model, compiled the model with the standard optimizer and the loss technique, and then we trained the model. After that, we have saved the model and named as OTBI underscore custom trained sample.model. Then we picked up the test image data set. We assigned the variable to xtest and then converted into normalization in order to pass it to the saved trained data model. Using the xtest normalized images, what we have for the 9 new images, we passed that xtest to the trained data set, and anything which matches very close accuracy, the appropriate label will be returned. And as we see that the labels are accurate 100% in this case, and then we went with the loop iteration to display the images based on the trained outcome, and the trained outcome label we are going to display on the test data set. I hope you understood this tutorial and you enjoy the tutorial. With this, I'm going to end this recording until I come back with another interesting tutorial on Python image processing. This is Saravanan Vajravel signing off from OneTouchBI. Goodbye.